Ladies,
Sir, good morning, sir.
Sir. So within another 5 minutes we'll start, sir. So Yerzhan is getting ready. So within
Yes,
another
sir.
5 minutes we'll start.
Yes, sir. Yes, sir. Wonder, sir.
சரி சொல்லுங்க சார். சார்
சார் பிபிடி ஃபர்ஸ்ட் பேஜ் நம்ம வச்சுட்டோம்னா பின் பண்ணிடலாம் சார்.
ஓகே ஓகே. பிபிடி உங்களுக்கு அனுப்பிச்சுட்டுமா இப்போ வாட்ஸ்அப்பில்?
சார் நீங்க எதுவும் பண்ண முடியாதா சார்?
ஓகே. பண்ணிடுறேன்.
ஓகே சார். ஓகே.
ஜெகதீஷ் இப்போ ஓகேவா?
எஸ் சார், விசிபிள் சார்.
ஓகே ஓகே.
சார் அந்த ஸ்க்ரீனை மட்டும் அப்படியே பின் பண்ணிடுங்க சார்.
அது எப்படி பிரிண்ட் பண்ணுறதுங்க?
பிபிடி மேல அப்படியே ஹோயர் பண்ணீங்க அப்படின்னா பின்
ஓகே
அப்படின்னு ஒரு ஆப்ஷன் வரும் சார்.
ஓகே ஓகே
அப்படியே மேல கொண்டு போனீங்கன்னா பின் வரும் சார்.
ஓகே 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 ஓகே.
வந்துருச்சாங்க சார்?
பார்க்குறேங்க.
ஓகே சார். சும்மா அந்த பிபிடி மேல நான் சென்டர்ல கை கொண்டு போனாவே வந்துடும் சார்.
ஜஸ்ட் ஒரு நிமிஷம் அவரை வந்துடுவாருங்க. வந்துடுவார்.
ஓகே சார். ஓகே சார். அவரே ப்ரெசென்ட் பண்ணுவாரா சார்?
அவரே ப்ரெசென்ட் பண்ணுறாரு. ஒன்றும் பிரச்சனை.
ஓகே சார். ஓகே சார்.
Yerzhan is ready. Yerzhan?
Yes, I'm here.
Okay. So you can present
Shall I
your
start?
screen.
Sorry?
Yeah, you can present your screen.
I can present my screen, okay. Just a minute.
Okay. So So before we are starting the presentation, I would like to introduce Dr. Yerzhan. So Dr. Yerzhan is an associate professor in Satbayev University, and he is also associate with Al Farabi Kazakhstan National University, and he has completed his bachelor, master's, and PhD degrees, all the three degrees from Al Farabi Kazakhstan National University in the field of mechanical engineering, and he's expert in modeling of as a turbulence modeling. After that, after his PhD degree, he's done a lot of research and development activities in the field of heat pumps in collaboration with NIT Calicut and also with our institute, Hindustan College of Engineering and Technology. And yes, initially he has got fund for around 1 crore for the Indian money for the project called solar assisted heat pump. Having some. So
Yeah, it's okay.
initially, so I'll Yerzhan, first I'll introduce you, then we can start your presentation.
Okay.
So initially, Yerzhan has got a research fund for the Indian money value of 1 crore for the project of solar assisted heat pumps for space heating. Then in collaboration with NIT Calicut and also with our institute, Hindustan College of Engineering and Technology. Later, based on that research outcome, he has got 3.5 crores rupees for a World Bank project to commercialize that concept. And he had done a lot of commercialization activities. And he's having some problems. So he is going to share the commercialization problems in this presentation. And also, he's got another 65 lakhs worth for the development of auto cascade solar assisted heat pumps for space heating applications in collaboration with myself, especially in the Hindustan College of Engineering and Technology. And he's also going to submit a new proposal on hybrid solar and geothermal hybrid heat pumps for in this year. So he's having a last 5 years. He's having an intensive research and development activities in the field of solar assisted heat pumps. I hope he's going to share his 5 years research experience, what problems he is facing when the product is going for a commercialization. So those information he is going to present. So and based on our research collaborations, we have published more than 10 journal papers, so in reputed journals. And I hope he's a right person to give the information about the solar assisted heat pumps, especially for heating up space heating applications, especially in continental climatic conditions like Kazakhstan, especially in Russian climatic conditions, because Kazakhstan is a part of Russian country. So, so I welcome Yerzhan to take over the session. I welcome. Please.
Yes, thank you for introduction, Professor Mukhanraj.
Thank you.
Welcoming dear participant. So my name is Yerzhan Belyayev. I'm from Kazakhstan. So Kazakhstan is not part of Russia. Please don't be. It takes independent from 1991. So I introduce Department of Applied Mechanics and Engineering of Satbayev University and Department of Mechanics from Al Farabi Kazakh National University. So I'd like to present you some results of our research activities. So first of all, what is the problem of this segment, this sector? So heating energy, according to International Energy Agency, just over 50% of heat produced was consumed in industry. For example,
Excuse me, sir.
Sorry?
Sir, your screen is not presenting, sir.
Screen on the.
Screen is.
You can pin your screen, sir.
You can pin the Yerzhan Belyayev second presentation PPT. Yerzhan, please wait. So he's having two these things available. One is for audio and another is for the video presentations. Yeah, now it's available. So another is available at the end.
Can you see my presentation? It's okay?
It's okay. Now it's okay. Jagdish?
Sir?
ரெண்டாவது ஒரு
Okay.
presentation இருக்கு பாருங்க. ஒன்னு வீடியோக்கு ஒன்னு ஒரு ஆடியோக்கு ஒன்னு இருக்கும். ரெண்டாவதுல இருக்கிறதுல தான் வீடியோ பிரசன்டேஷன் இருக்கு. இந்த ஸ்லைட்ஸ்
சார் பின் பண்ணணும் சார். எர்சான் சார் பின் பண்ணணும் சார்.
இல்ல இன்னொரு எர்சான் ஒன்னு இருக்கும். ரெண்டு எர்சான் இருக்கும். ஒன் ஃபார் ஆடியோ and another for வீடியோ. It's a presentation
Okay
screen.
sir. Okay sir.
Last Erzan. Have you got it?
So can I continue?
Just a minute.
Okay.
அவரோட ஸ்கிரீன் பண்ண சார் அப்படியே வேற பிரசன்ட் பண்ணாங்கன்னா மாறி இருக்கு சார்.
எதுங்க?
வேற யாராவது ஸ்கிரீன் பிரசன்ட் பண்ணாங்கன்னா சாரோட ஸ்கிரீன் போயிருது சார். ஸோ அதனால சாரை பின் பண்ண சொல்லணும் சார்.
பின். ஸோ எர்சான்.
ஆமாம் சார்.
ஸோ ப்ளீஸ் பின் யுவர் ஹலோ எர்சான். Erzan?
Yes.
So please pin your icon. This one.
PPT screen, sir.
Pin your PPT screen.
PPT screen. Just a minute.
Now it's okay. Jagdish?
Sir?
இப்போ ஓகேவா?
இல்ல சார்,
Is it
இல்ல
okay
சார்.
now?
ஸ்கிரீன் மட்டும் பின் பண்ணா ஓகே. Sir, have you pinned your screen, sir?
Yes.
Okay, sir.
Okay, we'll start. Erzan?
Yes.
You can, have you pinned the screen?
Yes, I think I pinned. This button is.
Yeah.
Just a minute.
Sir, if you hover over the screen, a pin option will come, sir.
So select the resume your presentation.
Hello? Erzan?
Yes. Just a minute. I try to pin.
Okay.
Visible.
Now it is visible.
Yerzhan, now it's okay.
No, sir, again it is gone, sir.
Yes, yes. Sorry for.
No problem, no problem.
Yes, so according to International Energy Agency, heat produced was consumed in industry, for example, process heat, drying, and industrial hot water use. Another 46% used for space and water heating and cooking application in building sector. So remaining 4% is the agricultural heating and drying process. So as we can see, the almost
Yerzhan,
yes.
you can use this slide presentation, this one. So total screen is visible.
Give your slideshow, sir.
Slideshow, going for slideshow.
Oh, sorry.
You can going for slideshow.
So press F5, sir.
And at the bottom, you can go for slideshow. The bottom. Okay, okay. Yerzhan, it's okay.
So 46% was used for space and water heating application. So as we can see, according to International Renewable Energy International Energy Agency, in 2017, 10% produced 77%. And heat consumption contributed almost 40% of energy-related carbon dioxide emissions. So as we can see, the market needs switching to renewable and other low-carbon heat sources. As a solution in a continental climate condition like Kazakhstan, Russia, and other Nordic countries, the problem is solved by supplying natural gas. But natural gas is not available everywhere. This is a short disadvantage of this. And the disadvantage of natural gas is CH2 leakage, low efficiency of the natural gas-based boilers, and CO2 emission still. The problem can be solved by using heat pumps. The mostly famous is a compression-based heat pumps, vapor compression heat pumps, in particular combined with renewable electricity. So, according to International Energy Agency, in 2019, around 5% of residential heat demand was shared by heat pumps. It is still very less comparing to the conventional fossil fuel-based equipments, as you can see from this diagram, and other renewable and hydrogen-based heating systems and electricity-based heating system. And according to UN Sustainable Development Scenario, by 2030, these heat pumps should reach 22% of this heat supply sector. So how much heat pumps are sold today in the world? So according to the, again, International Energy Agency data, European Union market is expanding quickly, with around 1.3 million households purchasing heat pumps in 2018. So United States, for example, heat pumps sales for newly constructed building exceeds 40% for single family dwellings, and it is near 50% for new multi-family buildings. So the principle of heat pump working, you are familiar, as shown in this diagram. So mostly heat pumps are classified by air-to-air, air-to-water, water-to-water heat pumps. So mostly this technology is widely spreaded and popular in mild, warm, and tropical climate conditions. For example, air-to-air heat pumps or reversible air conditioners is supply heat, both heat and space cooling and space heating application in these warm climate conditions and tropical conditions. And for air-to-water heat pumps is most famous in for water heating application, for domestic hot water, for example. According to this data, for example, China has a coal to electricity program that help raise sales to 1.3 million units of air-to-water heat pumps, especially in north part of China in 2017. And the water-to-water heat pumps is mostly used for ground source heat pumps and waste heat recovery heat pumps. And ground source heat pumps annual sales is not exceed 400,000 units. Half of them is in United States. So mostly because of United States has subsidies and tax stimulations. Government stimulate this kind of technologies for newly constructed building. Secondly, Sweden and Germany as the two leaders in European market. Around 30,000 units sale each year for water-to-water heat pumps in the ground source, coupled with ground source heat exchanger. So what kind of heat pumps is applicable in different climate conditions? For example, as I can say, air-to-water heat pump, that conventional vapor compression cycle, single stage, is most popular today, and it's used for water heating application. For example, that compact unit, heat pump water heater unit, or this kind of split units that outdoor unit is an evaporator and indoor unit is this water heating vapor compression cycle. So the disadvantages of this single stage vapor compression cycle, air to water heat pumps, for example, is it cannot deliver heat more than 50 degrees in low ambient temperature. below 0 -5 degree. So mostly in continental climate conditions like Kazakhstan, Russia, North China, North America, that in winter heating season, ambient temperature is drops dramatically. It's can reach -40 even less in north parts of Russia. So at that case, that single stage heat pump cannot deliver heat with a appropriate efficiency. Efficiency means here is a COP. So as we can see, that single stage heat pump is not applicable during heating season in that Nordic countries, but it is quite popular in mild climate, in warm climate conditions. For example, in the north part of India, where temperature in winter does not drop below 0. So at the same time, solar thermal heat. Solar heat, according to that International Energy Agency, one of the top 3 renewable sources driving that climate protection. For example, in 2019, solar thermal system produced 479 gigawatt thermal energy. This equivalent is 43 million tons of oil saved, or 138 million tons of CO2 emission avoided. So in this diagram shown the leaders of that solar thermal energy using countries. India is in the top, as you can see, with the annual growth with a 2% growth rate. So solar water heaters can be classified as direct and indirect solar water heaters. So in India and, for example, Malaysia case, you use that direct solar water heaters, which you directly mounted that solar absorber and storage tank on the top of the roof, and only working fluid is water. So because of temperature does not drops below 0, even below 10, so you cannot afraid to freeze the water, and you can use directly this heated water in domestic hot water application. But in Nordic countries, like North climate conditions, we use indirect solar water heaters with the 2 working fluids. The first loop is mostly used at antifreeze solution with a heat exchanger, intermediate heat exchanger, or heat exchanger can be mounted into that hot water storage tank. So this fluid is not mixed with that hot water in the tank. Mostly this fluid is an antifreeze solution. So according to our observations, that flat plate solar thermal collector is a most convenient and most reliable technology, but it has shortcomings in the North countries with heat loss, mainly convective heat loss due to that ambient temperature and wind. But vacuum type solar thermal collector is a good option for that Nordic climates. So how can we use both solar thermal technology, solar thermal collector, and heat pump? We can boost that heat pump efficiency, as we call it, a seasonal performance factor, by solar thermal collectors. So in this case, we can connect directly solar thermal collector. It is a direct expansion heat pump, or indirect expansion heat pump, so that solar solar loop can be the first stage to increase that low grade heat. So in National Institute of Technology Calicut, we start this work in 2015 with Professor Mohanraj and Professor Jairaj. As you can see, that photo of direct expansion solar assisted heat pump. In our case, for Nordic climates, for continental climates like Kazakhstan, we suggest to use these both technologies, solar thermal collector water heater and heat pump water heater, in parallel. So we combine these both technologies, not make it hybrid. So combination of these technologies can increase that seasonal performance factor, and especially for South Kazakhstan regions, where the warm days are more than cold days in that heating season. But still, for a single stage vapor compression cycle, if we use that air to water heat pump here, single stage, we cannot deliver that useful heat, required useful heat in extremely cold conditions. So, and that solar thermal collectors still depend on solar radiation availability. So only daytime we can store the heat in that water storage tank and use it for domestic hot water application, but for space heating application is not sufficient. So we test solar water heater in southeast part of Kazakhstan and north part of Kazakhstan, the capital of the Kazakhstan. So that efficiency of solar water heater in south part, of course, is much better than in north part. And here we face a problem with convective heat loss in that flat plate collector that decrease the efficiency of the system because of north part windy, and even in summer with available solar radiation and a highly windy case, heat rejection is less. So that's why for North countries we recommend use that vacuum type collector. So we made that efficiency calculation according to that heat balance equation and 2D heat conduction equation. The details of this calculation you can find in our papers and the reports, and I can share with you later if you're interested. And we built another heat balance equation for solar water heater. This is our own code, simple code for heat balance equation, and we can show here the theoretical heat that can be given by that solar water heater. But in practice, we can face different problems. Especially, we recommend to not mount the system, that hot water storage tank and solar thermal collectors, that distance between them should not exceed 3-4 meters. In this case, we can extract more heat if it is less. Then we can that distance will be large. Also, we use a Transys 18 simulation for that combined solar water heater and that heat pump water heater for the Nur-Sultan condition, that Nordic Astana climate. And here's a graph for 1 month's efficiency in January, cold case. Here's the annual efficiency. As you can see, in summer we can get the required heat, but in winter heating season we cannot reach the required heat. and that you can see in January condition, solar thermal collectors does not provide that much heat. And in this case, we recommend to use solar water heaters with additional booster, additional heat pump, or conventional natural hydrocarbon-based boilers booster. So even heat pumps has a shortage. So for Nordic countries, we recommend some other heaters. Here we make experimental testing for south part Kazakhstan, conventional single stage air to water heat pump, R290, R410A refrigerant. Here COP at -8, we can reach the good COP even at -8. And here the temperature in the different section of this heat pump. So here that engineering equation solver calculation for that single stage heat pump. The results for different refrigerants, COP for different refrigerants, and here is the pressure ratio. And pressure ratio is a very important parameter, because of according to the literature, pressure ratio does should not exceed 9 and 10. This is a dimensionless parameter. So as we can see that propane R32 and R410A is in this range, so that for cold climate we can recommend these refrigerants at a temperature not below -7, -8. As you can see from the graph below, the COP at -8 is more than 2.5. So below, if we decrease the temperature, accordingly COP is decreased, and there is no usage of this heat pump in this cold climates. To solve this problem, we propose this solution. The solution, of course, is a combination of these technologies. Especially we can combine three technologies: that heat pump, conventional natural hydrocarbon-based fuel heaters like gas boiler or coal furnace, and solar thermal collectors. But of course, these three systems can be combined, but it makes the system expensive. So we can choose combination according to the climate conditions, according to the annual climate characteristics of this region, combination of collectors and boilers, collectors, heat pump, or boilers or heat pump. So we make this kind of simulation, and we working in this direction. Another solution is instead of using these hydrocarbon-based boilers, we use a two-stage cascade heat pump, air to water heat pump. So the idea is using of sequentially connect this vapor compression cycle to heat this water. Of course, this is theoretically a very good idea, and in research and development point of view and R&D point of view, it is a very good concept. But in commercial point of view, of course, it have shortcomings. According to that calculation, and we build this according to the calculation in engineering equation solver, we try to simulate that intermediate heat exchanger and different type of intermediate heat exchanger for the cascade system. And this configuration is the most efficient among these different cascade configurations. And this 410A and R134A system, that first loop is a 410A refrigerant, second loop is 134A. the COP can reach 2.2 at minus 30 ambient temperature. Of course, the system as a configuration, as a concept is very good, but commercially is not viable. This result of calculation, air to water two-stage cascade heat pump for different refrigerant pairs. We made a simulation for different refrigerant pairs, and we recommend this R32, R134A, 134A, and propane, R410A propane systems to run this cascade system for water heating and space heating application. So as you can see, we can get a good COP even at minus 30 and minus 40 ambient temperature. Of course, it is good COP. It is a relative parameter. So, for example, European standards COP is should be not less than 3, not less than 2.5. So standard is changing, and every year that for heat pumps improvement is going on, and COP2 is not good for European market condition, for example. So also as a concept, as a research and development concept, we suggest together with Professor Mohanraj and Professor Jairaj direct expansion two-stage cascade heat pump. So instead of using air source evaporator, we use solar thermal collector. So this also we make that calculation and COP even 1.8 at minus 30. Also comparatively it is good. It gives a good condition, but standards does not allow this much COP, and it is in research point of view interesting concept. To avoid these two compression cycle and accordingly that electricity consumption for two compressors, Professor Mohanraj and we suggest that new solar assisted auto cascade heat pump configuration. So what is the idea? The idea of using that binary refrigerant mixture initially, and using one compressor, only one compressor, and different heat exchanger configuration to save this temperature range for cold ambient temperatures, and save that heat delivery rate and COP. So we reach the COP 2.7. Theoretically, we reach the COP for 2.7 for refrigerant mixture R32 and R134A. We still cannot build this. Didn't build this configuration, but with under process, we in near future build this configuration for research and development purpose. Also, this system is recommended for water heating application only, so domestic water heating, because solar energy available only in daytime, and we cannot reliably supply heat to the Nordic countries. We work as a suggestion, as a solution, that combination of a conventional heat pump, air to water heat pump with a gas boiler. This is a very viable and commercially viable concept today. Households, buildings already has that heating system based on the natural gas or coal in our countries. So if we can give them the new configuration to reduce that CO2 emission and to increase the efficiency of the system with the heat pump integration, it will be good in terms of economy, environment and sustainability. So we work on this, and results we can show later. As a solar energy integration with a heat pump, another concept is a solar PV integration with a heat pump. So solar PV with a DC inverter compressor in that air-to-water heat pump or air-to-air heat pump or solar PV air conditioners. It is very popular in this in your countries, in the tropical countries, and I think it is in commercial point of view it can be viable in that in both Nordic and South countries. Also, we not have results on this concept. It can be future research and development idea. So another very viable and commercially stable concept, technically and commercially, it is a water-to-water heat pump. We made that simulation, and we can reach a COP more than 3.4. Water-to-water heat pump can be used, can be utilized heat from low-grade ground source heat pump. We are now working in this direction together with Professor Mohanraj and European partners from European universities. So, but this system is expensive because of ground source heat exchanger drilling cost is expensive, and research should be research and development needs to decrease the price of drilling cost, installation cost of that ground source heat exchangers. As you know, that ground source heat exchanger can be vertical type or horizontal type. So for North continental climate condition, it is recommended to use vertical type heat exchanger because as you can see, the Earth's temperature by depths after 15 meters, it cannot be changed. There is no changing in the temperature. So we can use this low-grade heat of that heat pump. What kind of problem in this case? After several years of usage, so the ground can freeze, and that COP of heat pump can drop after, for example, 5 and 6 years of operation of that heat pump. To solve this problem, we can combine this system with solar thermal collectors, and excess heat in summer we can store in this ground, or excess heat in summer during the cooling of this space we can store in this ground, and we can reiterate that thermal and physical properties of the ground, of the soil. Of course, there is a lot of research needed in terms of heat and mass transfer in that soil. What kind of soil and rock, what kind of underground flows? Is there any underground deposits of hot water? So geothermal deposits. So there is a lot of research needs, and this is a huge direction, but this system reliable and sustainable for the Nordic countries, and COP for that water-to-water heat pump block inside of the building can reach can get a higher rate. So that's why we recommend this technology for these regions. Of course, for a single house, in terms of commercialization, it is expensive. So for district heating application, that system can be viable in terms of economy as well. Also, water-to-water heat pump can be used for waste heat recovery. So waste heat can be generated by large, also this technology can be applied to the large industrial scale heat, waste heat from the industry, from the wastewater, from that big refrigeration units for the ice from the grocery store, from the ice skate rink, and so on. So for small scale application, this water-to-water heat pump for waste, small individual house cannot generate so much waste heat, and it is recommended to use it in industrial scale. So what is the market opportunities for the heat pump? That market size in Kazakhstan case, it is every year 1 million private houses, excluding that agricultural facilities and warehouses. So market growth is 15% of annual house building, new house construction, and less than 56% of Kazakhstan does not have a availability to natural gas. There is no electricity shortage because we has a lot of coal-based power plants, and there is no electricity shortage in Kazakhstan. Renewable electricity market is growing, and the combination of this technology with renewable electricity make it more sustainable. And what kind of commercial barriers today? I talk about Kazakhstan case, and we, as I said, Kazakhstan is a resource-rich country, and we export a lot of oil, gas, and natural resources. And of course, the price of hydrocarbon fuels here is cheap, and I can say it is cheapest among the world. So as you can see, natural gas price is very cheap, and electricity price is very cheap. That coal-powered power plant generate that electricity is cheap. So the cheapest price, it is a very main barriers in the development of this kind of technology. And the second barrier is the cost of equipment. Unfortunately, we cannot, in Kazakhstan, there is no production of components of that heat pump. For example, I just talk about heat pump case, components of heat pump, and even assembling shops, there is no assembling shops. And as a recommendation, it is suggested to build that assembling shop and maybe import that components of the heat pump from the China and make it cheapest the product, and working on the tariff policy, and that make that renewable energy systems competitive with the existing hydrocarbon-based systems. Of course, we have, according to the UN and Sustainable Development Goals, Sustainable Development Scenario, we have to reduce the CO2 emissions, and we have to develop these technologies. I think in Malaysia, in India, the same situation, and you have to increase these renewable energy systems to achieve the sustainable development goals. So in this slide, I show the comparative of operational cost of the heat pump. For example, we take that ground source heat pump with COP4, assume that COP4, we assume that's ambient temperature -15, that house is a 100 square meter house area. We just take as an example and provide that heat to this house with different heat source: electricity, coal, natural gas, and heat pump, solar assisted heat pump. So we don't take the price of that equipment. We just calculate according to the current tariffs in Kazakhstan the operational cost. As we can see, that heat pump is number 3 after coal and natural gas. So if it is almost the same with the natural gas. So if currently government make subsidies to the tariffs, natural gas tariffs, electricity tariffs, for us it is convenient to decrease the electricity price, but increase the natural resource price. That make that heat pump and other renewable energy systems benefit, competitive with current systems. So research and development opportunities. So we are working also on develop that CFD codes for well, we not develop, we use that CAMSOL multiphysics CFD tool to simulate the two-phase flow heat transfer in that heat exchanger, especially in that evaporator and that condenser of that heat pump with that phase change during boiling and condensation. That is very interesting task in terms of research, and in this direction we have PhD students who works in this direction, and this is a condensation case for R134A refrigerant as a two-phase flow using ANSYS fluid. So further research needs. So further research needs. It is first increasing standards of heat pumps efficiency, increasing of energy efficiency and environmental aspects of existing hydrocarbon-based heating systems for continental climate. So this means that we cannot avoid the existing hydrocarbon systems, but we can increase their efficiency because of this system are reliable, especially in the cold countries. So we can increase of energy efficiency of ground source heat exchangers to make soil by using excess heat of solar energy, that solar seasonal thermal energy storage research, especially for continental climates, reduce the cost of heat pumps for the equation with the existing heating systems, in particular ground source heat pumps, search for the best combination and hybridization of configuration of vapor compression heat pumps with the existing heat supply systems. Search for the new solutions based on absorption heat pump, improving heat exchangers, and other components. For example, improving that vapor compression heat pump cycle with ejector, with other new combination with other systems. And of course, a two-phase flow heat transfer simulation, two-phase flow heat transfer investigation of boiling and condensation. It can be CFD research and experimental approach and so on. And conclusions. Conclusions made for especially with accent to commercialization point. Solution for one, it is for continental climate condition, best solution in terms of efficiency, environmental friendliness, less payback period is solar assisted ground source heat pump, water to water heat pump for district heating application. Second, water to water heat pump, best energy efficiency, environmental aspects, less payback period are industry and industrial refrigeration unit waste to wet heat recovery application. It is my suggestions. Maybe if you not agree, you can later tell your opinion. Small heating capacity air to water heat pumps for water heating application as a best in combination with hydrocarbon fuels for continental climate. In combination with solar thermal collector and solar PV, it is good for any climate condition, especially solar PV and air to water heat pumps. I think it is good for Indian case, for Malaysia case, and other tropical monsoon countries. Of course, you have during monsoon your solar system efficiency is drop, but even because of you have a ambient hot ambient conditions, I think that solar thermal water heaters and solar PV based water heaters are the best in your countries in terms of commercialization. Of course, there is a lot of other technologies like concentrated solar collector. It is difficult. It is more need more how to say operational cost is expensive for that systems. But these systems based on the existing proved commercially viable systems. Solution 4 is a flat plate solar collectors, or maybe the PVT collector based water heaters, convenient in operation and as a best solution from the commercialization point of view in tropical, subtropical climate like India and Malaysia. In solution 5, for continental climate condition, it is recommended to use vacuum tube collectors based water heaters, since less heat loss in windy and low ambient temperature conditions. But of course, that vacuum type collectors maintenance is expensive. So that's why there is different solution for one of the solution for continental climate is a combination of existing coal boilers, gas boilers with that air to water heat pump. Maybe partially air to water heat pump can make domestic hot water, and existing system make that heating system, provide the heating system. So this is my vision of and our results which we have today. If you have any question, please, you can ask.
So thank you, Yerzhan, for your excellent presentation on the heat pumps for space heating applications. Now I request the participants to post your questions in the comments box so that we can answer one by one. So I request the participants, please post your questions in the comment box so that we can answer one by one. So I hope Yerzhan is having a lot of research funding, especially for the development of heat pumps for space heating applications, especially in Kazakhstan climatic conditions. And he also developed portable ambient source heat pump, solar source heat pump, and also smart heat pumps for especially for domestic and small capacity residential applications. And is when it goes for commercialization because the Kazakhstan is very rich in energy resources like natural gas, uranium, and coal, but the cost of electricity is very cheap. So because of those reasons, they're facing a lot of commercialization barrier, but they're very good in because they have the environmental aspect. It is very good because it is an energy efficient. Suppose if 1 kilowatt of heat electricity is given to the system, that will produce 3.5 kilowatt of heat output. In that aspect, we can see it's an energy efficient and environment friendly. So the people will not agree when we say about this environmental at this junction. So the conditions will change. Definitely, the heat pump is going to be one of the good sustainable solution for heating applications. Especially heating demand is required. For example, continental climatic conditions of Kazakhstan is having a heating demand for 7 to 8 months. I think Yerzhan is 7 to 8 months is heating demand.
Sorry.
Hello.
Yes.
Heating demand is for 7 to 8 months.
Yeah, 7 to 8 months. Yeah.
Kazakhstan for space heating is 7 to 8 months. Is it?
Yes. From mid-October to mid-April.
Okay. 7 to 8 months heating demand. So it's very essential to have some sustainable solution. There are so many things. So I think that Yerzhan and his team, they are starting from the scratch. But it's a long thing. It's a long travel to make this product as a commercial version to reach the customers, to satisfy the customers. And it should be like a standardized product. It should be available in the market. One can buy and you can install like an air conditioner for space heating. So it's a long. It needs a long journey to complete this entire concept. But the Yerzhan is taking a good initiative. I hope this outcome of his research definitely will have good commercial value in future. Definitely the heating demand is very high, means definitely we need some sustainable energy efficient and environment friendly solution. So definitely we'll have a good, we'll expect good market value. So I hope, I think he's having now he's going for one more new project called geothermal assisted ambient solar assisted heat pumps. I think he is going to submit this proposal along with myself as a co-principal investigator. So I hope we'll get because he's working in a high reputed government funded university in Kazakhstan. So definitely he's having a good chance to get the research funding. But definitely, so is that outcome is also is more useful for the Kazakhstan climatic conditions. So, Yerzhan, shall we go for this questions session? Interaction
Yes,
session.
please. Yes.
So just a minute. I'll. Base heat pump in solar. So, what is the effect of wind speed on performance of cooling system? Your audio is not clear, so please make it audible.
Audio is not clear?
Audio, you can make it more audible.
Now is okay?
Yeah, it's okay.
So effect of wind speed. It is a good question. In that heat balance based mathematical model simulation, solar thermal water heater, we saw according to that our wind rose. Wind data from the meteor station, we see that effect of wind is very high to the especially convective heat loss during wind blowing through this.
I'll answer this one. So definitely this wind velocity is having a major influence on this performance of the solar assisted heat pumps. But if you are using some glazing, so we can reduce to some extent, because because maybe if you are using some glazing over this evaporate observer plate, so we can reduce 70 to 80% of convective the wind velocity problems. So most of our installations in Kazakhstan are having some glass type solar collectors. I think we are to reduce the convective losses from the observer plate, especially for some solar heating applications. And maybe a right answer for that question. So no problem. So we'll move to the another question. Is it possible to install domestic borewell having a 500 feet? So for the geothermal installation.
500 feet is how much?
It's very too high depth. So
meters.
The participant from India is asking this question, but I suggest for this question, for climatic conditions like India, geothermal energy extraction is more expensive, because the solar energy is because 70 to 75% of Indian geographical location is having enough is identified as enough hotspots of the country. So to have enough hotspots to have a very good solar radiation. So the availability of solar radiation is more sufficient to if we harness those heat availability in the 75% of area, will get very good energy output for heating as well as for the energy production, for electricity production.
Yes.
Geothermal energy extraction, especially for Indian climatic condition, is is more expensive. But in one few research and development studies have been carried out in IIT Roorkee, I think for some geothermal heat extraction, especially for some heating applications. So I think for south part of India there is no much need, but 500 feet is more enough. Suppose if the properties of soil is also very essential, because we have to make a very detailed analysis of the characteristics of the soil, how much the heat retaining capability, how the heat can be distributed, all those things. If we have to make a study, then we can go for geothermal energy extraction, but it's more expensive, especially for South India. So, and another question, what are the limitations of heat pump in solar?
Sorry, Professor.
Yes.
can I add
Yes.
a few words about the geothermal? Yes,
Yeah,
you are
yes,
right
yes,
that
please, yes, please.
geothermal energy is not how to say applicable for Indian case, because you have enough solar radiation. You don't need that space heating application. You don't need only space
Yes,
cooling.
yes,
But application of geothermal energy in India can be the deep borehole wells for
yes.
even 2 kilometers, 10 kilometers boreholes for in the future for electricity generation that make that heat can create steam for generate electricity. This is as application of geothermal energy in future for India, as my suggestion.
Okay, okay.
Okay, but for a
Uh,
shallow heat exchanger, like 500 feet, maybe it's relatively shallow, we can say.
okay.
For geothermal heat pump application, um, you can use for space cooling, but I think it is expensive, and you have another solution for India.
Yes.
Maybe application of geothermal heat pump is not need.
Yeah, okay,
Yes.
okay. And another thing, what are the limitations of heat pump in solar system? What are the limitations of solar assisted heat pump?
What are the limit of solar system in heat pump?
Limitations, drawbacks.
Limitations. Okay. So if we connect, as I show in that scheme, that here, solar collector as a booster for the heat pump. So it, of course, it has a limitation because of you cannot operate during nighttime because you are depend on that solar radiation. But if you can use in parallel, you are not you are independent from solar system, but you are dependent on ambient temperature only. So you can, if it is Indian case, so parallel usage of solar water heater and air to water heat pump is independently provide heat. But accordingly, you can provide some control system to switch according to that available of solar radiation or this system separately.
Okay.
So my
Okay.
my answer is a limitation in terms of solar radiation availability only if you use solar thermal system as a booster, not in parallel.
Okay. Okay. Yeah. Yeah.
Mhm.
And one more question: can the heat pump is working in non-sunny days?
Heat pump, yes. Ambient source heat pump is can work on sunny days,
So
but
I also give one
for
more suggestion. If the
yeah,
solar heat pumps, if it is provided with unglazed one, during sunny
yeah, yeah,
days, it will extract the energy from solar, and during non-sunny days, it is extracting the energy from ambient sources due to the temperature difference. And also, because most part of the South India is having high humidity, and because of this condensation, during the condensation of this moisture, humidity present in the air, that will release some amount of latent heat. That's also it provides as a heat source for the heat pump. Suppose if it is unglazed one, it will be more effective, especially for hot and humid climatic conditions. So that may be another solution.
yeah, yeah,
Okay.
yeah,
And
yeah.
another
Unglazed
question.
solar collectors good, yeah, for tropical condition.
Yes, yes,
Yeah.
yes. And another question for our another question is there any practical feasibility for solar air conditioners? So I suggest them. I gave one suggestion. So it is possible to because most of the inverter air conditioners are we can. It is possible to integrate with the photovoltaic panel. So whatever the photovoltaic panel generates the electricity, it is directly connected with the air conditioning system. It is possible. So for if it is connected with the according to the power rating of air conditioner, we can install the PV panels, extract the energy, and it can directly feed to the air condition. That is also possibilities there. But You have to design the PV panel requirement and to meet the power requirement of the power rating of the air conditioner. That's also possible. And another question, nowadays all are using electric power to run the motor, but solar is a renewable energy. So how much cost to run the submersible pump to run? So Arvind sir, so I will give a answer for this question. So that depends again. It depends upon the cost of the capacity of the pump. So how much capacity of pump you need to run, and the cost of inverters are now it gets reduced. I think it is suggested to use variable frequency drive motors because the variable drive motors design is slightly different from the conventional motors. So if you are going for a 5 HP photovoltaic based water pumping system, if it is for a submersible case, it comes around 3.5 lakhs. Including inverter cost, pump cost, PV panels, everything all put together, it comes around 3.5 to 4 lakhs. I don't know the exact price. I don't know the exact today's market cost, but the government is giving some subsidy to for installing this type PV water pumping systems. But I don't know. So you are asking the cost. I don't know how much exact cost. And again, if you go for the payback period, it comes around 7 to 8 years. So 7 to 8 years means then we have to think and we have to go for the investment. Suppose if the payback period is 3 years, 4 years, then it's you can recommend very well. You can straight away can go for this PV water pumping system. Now it comes around 7 to 8 years. That's a big problem. There is a big barrier for the commercial version of this photovoltaic water pumping systems. Okay, so and another question: is there any practical feasibility for solar air conditioning system?
Practical feasibility.
Yeah.
Solar air conditioner system. So as you say, solar air conditioner can be
panels
with PV, with solar PV or solar air conditioner with solar thermal. I think solar thermal application air conditioner in the first day, Professor Sopian gave an extensive explanation. I'm not expert in that area, but air conditioner in, for example, in our climate, continental climate, we use air conditioners. Is also has a feasibility application, but as for electricity generation, to that, for example, inverter type, DC inverter type air conditioner, PV can be used. I think this type can be in terms of commercialization, this can be useful, but there is a lot of solutions like the first day we see that presentation about different different types of solar assisted cooling systems. So I think you can see this presentation and you can get your answer.
Okay. And another question: can the heat pump can be used as a room heater without using fossil fuels? They're asking on that question.
Yes. It can be used without using the fossil fuels, especially if we properly install that geothermal heat pump in that cold climate with that heat storage, ground source heat storage application, underground heat storage possibility. It can be used without any.
I also add one point, so we can even connect with the PV panels. We can connect with the PV panels for producing the electricity that will meet the demand. So it's also possible.
Okay, yeah, but yes, I think for PV panels we need a small scale application, like small scale heat pump, small scale air conditioner. Small capacity.
One more question. In solar heat pump installation, cost meets the expectations in our country. Driving maintenance cost seems to be very expensive. So I answer this question. In solar assisted heat pumps, again we can say the solar assisted heat pumps is again in the research level. It is not in the commercialized product. It's not available as a commercial product. So because it is having so many commercial barrier.
Okay. Is it question or is it?
It is not consistent, so which may affect the hello.
Yes, yes.
Which may affect the performance of the solar assisted heat pumps. For that, we have suggested some heat storage materials, everything. But all put together, we cannot. So it is possible to. It is feasible because this 75% of Indian climatic conditions are having enough solar energy potential to meet the year-round demand. So it is possible to have solar assisted heat pumps for drying, desalination, water heating applications. So it is possible, but the cost wise, it's also it will become cheap. Suppose if we go for in large numbers, it is also possible. And another question: what is the scope of solar heat pumps used in rural areas? Can justify in terms of cost and utility? So I gave this. I will give the answer for this question. The scope of solar assisted heat pumps in the rural area is possible, but even if there is no grid connectivity, it is possible. So we can use some PVT collectors, so photovoltaic thermal collectors. The amount of the photovoltaic panel power generation can be significantly increased if you are integrate with the evaporator coils. So we also done a lot of studies on this particular thing, and we made this system as a zero energy heating systems. Again, I am saying it is in the research level. So after years together, after at least 5 to 10 years, the people will start thinking of using autonomous using of autonomous heating system, especially for water heating and drying. Recently, we have developed one heat pump with zero energy water heating systems. The electricity produced by that PVT collector is capable of running the system and also having the excess electricity which is connected to the grid, so that such type of systems will make the heat pump will self-sustainable, and also it is possible to provide zero energy heating systems. That's possibilities there. Then how much maintenance cost is needed for the pump? So that it depends again. It depends upon the case to case. We cannot say, we cannot standardize this maintenance cost. Then remaining, so these are some of the questions we are posted in the comments box. I think all the participants have got some good information from the Yerzhan's presentation. I think Yerzhan is doing a lot of research and development activities. Hope his research and development activities and heat pump will have some good commercial value, especially in the countries like Kazakhstan. And definitely we'll have a future session on further developments of heat pumps in this research laboratory. I thank you, Yerzhan. I thank you for your spending your valuable time and valuable information from your side to share with us. So I thank you.
Thank you for your attention, for invitation.
Okay. Yeah. Okay.
Many thanks, Professor. Yeah, for cooperation. Yeah.
So any other questions, please? So okay, we'll see you, Yerzhan. We'll see you.
Yeah, thank you, Professor. Bye. Thank you to all for today's presentation.
So, tomorrow is having is a last presentation. It is on solar air heaters. It is on solar air heaters. Is a resource person is the Arun K. Raj. So he's a research scholar. He's completed the PhD and he's waiting for his viva, and he's going to give an excellent. He's done a lot of research and development activities on solar air heaters. I hope his he is going to share his research and development activities during his PhD work. So he's published more than 10 papers out of his PhD work. So we'll have a good presentation, one more good presentation by tomorrow. So I welcome you all for tomorrow's presentation. Thank you.